Hi everyone, in this video I am going to explain about the Doppler effect in light. Already the same thing will be in the waves chapter. Doppler effect in case of sound waves. Already we learnt about that one, Doppler effect in sound. In this case, how the Doppler effect will be applicable to the light waves. Very small topic but interesting one. What is mean by Doppler effect and what is mean by redshift and what is mean by blue shift. So that is only our topic here now, children. So up to now you didn't subscribe my channel, then go and subscribe my channel and press the bell icon for latest notifications. Okay, I am going to the topic now. Today's topic is Doppler effect. And from that we have to explain about the redshift and blue shift. Blue shift. Here first thing is, what is Doppler effect? So on that time we learn what's that, there is some change in frequency here by the observer when source and observer both are in relative motion. The apparent change in frequency here by the observer when the source and observer both are at relative motion. That is the Doppler effect in the same here. Doppler effect in the sound waves. The same thing will be there. On that time we are saying now sound. Now in this case we can say that light. The apparent change in frequency observed by the source of light when the source and observer both are in relative motion, that is called Doppler effect in light. So once go to the same example, previous example. Here this is a railway station, some railway station platform, and this is the platform. On that platform one boy is standing there. One boy is railway station and one person is on the platform, and this is a track. On that some train is coming. So train, same train example. This is the train and he is the observer. He is the observer. While a passenger or a person or observer, he was waiting at the platform for a train. When he was find that when the train is far away from the platform and it was some whistling horn. When the train is very far off the platform, he found that here the intensity of or the sound produced by the horn should be very less. That means he was listening less frequency of sound. When the same train approaches to the platform, then he was observed that the sound of the horn will be increases. When again the train should be moving away from the station, then also he observed that the sound horn or the horn sound should be decreases. Clear? While he was waiting at a platform, and he observed that when the train is far away from him, he was listened that the sound of the horn is very less. When the train is approaches, during that the sound of the horn should be increases, and again while it is crossing the station, then also the the sound should be decreases. That means what? There is no change in actual frequency of sound produced by the horn of the train. The horn sound frequency should be constant. But what is the difference there? What is the difference? The sound observed by the observer, that is the different. Sometimes he may listen more sound and sometimes he may listen very less sound. The difference in, where is the difference? Frequency is by the observer. So I was given examples for Doppler effect regarding the sound chapter. I already uploaded one video for that. So if you want more explanation for that, just go over the playlist second wave chapter second year, then go and search there. So many examples are there. Clear? So that means here during those examples, what you have to observe, the actual frequency is no change, but the apparent frequency will be changes. The frequency observed by the person will be changes. Here the same phenomena applicable here. Here relative motion means there are three conditions here. That is, here maybe the observer is at rest. Observer is at rest. First thing is here there are three conditions. First one is observer is at rest. Then S is in motion. S is in motion. And second time the observer is in motion. Then source is at rest. Source is at rest. And third one, when both are in motion. Both are in motion. Clear? So here now, in this case, what you have to observe, the same example I am giving here. While the train is coming to the observer during this, I am saying now here, during the night time. During the night time, again same example I am giving. If the observer is at rest, observer is at rest on same platform, and that is the night time, and he was find that one train is coming from long distance. For that some light is there. Light is there. He found that some light of engine should be increases. When the train approaches to the person, what he was observed, the intensity of light should be increases. Clear? While the train is moving away from the observer, then what you can find, less amount of light. That means here, while the train is in motion, the light which is attached to the engine, that should be also in motion. When the train approaches the platform, the intensity of light should be increases. Intensity of light should be increases. While it is moving away from, you must find that the intensity of light is decreases. That means there is no change in intensity of light should be produced by the, what it is? Source. That means what? The light of the train engine should be always produce the same amount of light. That will use the constant number of waves. But what is the difference? Sometimes the person can find that he was observed that when the train is far away from the platform, he found that the intensity is less. When the train approaches the platform, he was observed that the light intensity is increases. When the train is leaving the platform, what you observed, again the light should be decreases. The amount of intensity produced by the light of the train should be decreased while it leaves the platform. You have to observe this one during the night time season. So here in this case, the light is taken as source. The engine light should be taken as the source, and the person who is at the platform, he may taken as the observer. Now observer is at rest, source is in motion. In that time, the source is moving towards the observer and moving away from the observer, and the observer is at rest. Got my point? So in this case, we can define the Doppler effect like this. What's the Doppler effect? The apparent change in frequency of light. The apparent change in frequency of light observed by the observer when source and observer both are in relative motion. Clear? The apparent change in frequency of light of source when the source and observer both are in relative motion, that should be called here Doppler effect in light. Doppler effect in light. So in waves, regarding the sounds, we can say that source of sound. Now here source of light. So no need to confuse. So now I will go to one example here. So here for example, it is the source and he is the observer. He is the observer. Clear? Source and observer. When both are at rest, here we are showing that the frequency of light is nu and wavelength is lambda. Clear? Source and observer both are at rest. Here source means what? Nothing but light source. I am drawing here light source. This is light source. The source produces the light. That means the light waves are coming and they are moving towards observer. They are moving towards observer means they will have some frequency and wavelength. That should be shown like this here, nu and lambda. Here in this case, again I am showing now here, in this case, the source, look here, this arrow mark you have to identify. The source is moving away. For this, source is moving away. Clear? In this case, the source and observer both are at rest. Now, here what I am telling, the source is moving away. So that means here the frequency is decreases. That's why you have to observe the diagram now here. We have to say here the frequency is more. That's why the pulses are very close. And now here, yes, it is moving in this direction. Source is moving away from the observer. Moving away from the observer. In this case, wavelength is increases. How we can show? Wavelength is what? Lambda. Lambda is increases. Wavelength is increases. I am showing like with arrow. Upward arrow. And which can decrease? As frequency is decreases. Frequency is decreases. Clear? And after that, again, this is the source and again this is the observer. Clear? Now I am showing that. So in this case, source is moving towards observer. Source is moving towards observer. Then wavelength is decreases. Wavelength is what? Decreases. I am showing downward arrow. That means wavelength is decreases and frequency is increases. Clear? Frequency is increases. So we have to observe the diagram very clearly and carefully. When both are at rest, we have nu and lambda it is there. Nu and lambda it is there. Here in this case, source is moving away. Source is moving away. Generally what we say, wavelength means distance traveled by the wave is called generally wavelength. That's a general definition. So you have to observe here. Already up to here lambda it is there. After that again it should be going. That's why wavelength is increases. What's that? Wavelength is increases. So here wavelength is increases. Clear? And now in this case, you already have to observe the source is moving towards observer. Source is moving towards observer. Again, this means what? Source means what? This is light only. Light source. Don't confuse that. So here, this is the one particular case. What is that? Source is moving away from the observer and source is moving towards the observer. In this case, do you know what? Do you want about the redshift and blue shift? Redshift and blue shift. So for that, you have to know about the spectrum. Generally, the spectrum consists of almost all here. In this case, we know about that one. It should be having 7 colors. So, what are those? WIP-GR colors. WIP-GR. So, WIP-GR, the spectrum, light spectrum has colors like this: VIB, violet, indigo, blue, green, yellow, orange and red. That is the clear. Already we know about that one. Which color has more wavelength? Which color has more wavelength? Yes, red color has more wavelength and violet has minimum wavelength. And violet has more deviation, red has less deviation. So that's why here, tell me now, when we are getting the red shift and when we are getting the blue shift. In a light spectrum, we are moving towards the, here wavelength is increases. That means what? While we are moving from violet to red, the wavelength is increases. Wavelength is increases. When the wavelength is increased, actually, clear children? In the light spectrum, 7 colors are, they are violet, indigo, blue, green, yellow, orange and red. In those, the extreme colors, violet and red. In these two, violet has more deviation and less wavelength. Red has more wavelength, less deviation. That's why here, while we are going from violet to red, the wavelength is increases. That's why the shift which can be formed when the source is moving away, from the observer, that should be called here red shift. Clear? In a visible spectrum, if you are moving towards the red color, that should be taken as red shift. That should be possible only when the source is moving away from the observer. Initially I explained what's that. When the source is moving away from the observer, the lambda is increases, nu is decreases. Clear? That is about the red shift. And next thing is here, what about blue shift? Blue shift. Blue means what? When we are comparing the blue and red, which is having more wavelength? Red only. Blue has less wavelength. That's why in this case, what you have to say? Wavelength is increase for red. Now for blue color, while we are moving towards the blue color, what you observe? Wavelength is decreases. That should be called here blue shift. And this is what we call red shift. That means when the source is moving towards the stationary observer, the frequency is increases. In this case, while we are in a spectrum, if you are moving towards the blue color, the frequency is increases and wavelength is decreases. That's why it is called blue shift. What we call blue shift. Blue shift. When we can observe the blue shift, the source is moving towards the stationary observer. So children, this is about the Doppler effect, red shift and blue shift. What is Doppler effect? The apparent change in frequency of light. When the source and observer both are in relative motion. To explain the blue shift and red shift, we have considered one example. What's that? When the source of light and observer both are at rest, the frequency is taken as nu and wavelength is taken as lambda. After that, when the source is moving towards the observer, what do you observe? Lambda is increases and now here nu is decreases, frequency is decreases. Then if you can observe or if you can find any spectrum, then that is because of here red shift only. That means here if we can consider a spectrum, in that spectrum red color has more wavelength. That means when we are moving towards the red color, what do you have to say? Wavelength is increase and frequency is decrease. That is what we call redshift. In a spectrum, if you are moving towards the red color, the wavelength is increase, frequency is decrease. That should be only possible when source is moving away from the observer. That is about the redshift. And now here, when the source is moving towards the stationary observer, then frequency is increase, upward arrow, and wavelength is decrease. That's why here what I have to say, in this case we have to say that in a spectrum, if you are going towards the blue color, frequency increases and wavelength is decreases. That phenomena what we call blue shift. So children, I hope you understand. So this is about the Doppler effect, blue shift and red shift in case of light. So I hope you understand. If you can understand this video, like and share and comment the video, children. We will meet in the next video. Bye, take care.